So this is Mr. Fitzgerald. I know a lot of you in class today were were not in class today because you were taking an AP test, so I thought I'd go over what we did. And you can expect more of these videos over time. What we did is we compared what the properties and the way we describe ellipses with something new, hyperbolas, which are they look a lot different, but they have some similarities in what we see in their equations and their the design and their formulation. So we knew that the bare bones definition of an ellipse is that we have these two focus points, and they are inside on the major axis of the ellipse. And if we were to draw the distance between these from each of these focus points to any point on this ellipse, that distance is going to be constant, the same for every possible pair. So we know an ellipse is generated by the set of points such that the sum of distances away from two fixed focus points is constant. We change color. Similarly, a hyperbola is generated by the set of points such that the difference of such distances is constant. So we're going to compare the formulas a little bit. By design, we just know, okay, it's the sum versus the difference of these lengths. With ellipses, we have two different formulas that we use. Depends on what the major axis is. The major axis meaning the longest side, right? X squared over a squared plus y squared over b squared is equal to 1. Or we can have x squared over b squared plus y squared over a squared is equal to 1. And this is important because we are told we must follow that a is greater than b, because a determines the major axis, the longest side. A determines the major axis. If you wanted to find the value on the major axis of these focus points, which we would call C, you follow the equation as we did. C squared is equal to a squared minus b squared. So that's just a quick refresher, but let's go over how that compares to hyperbolas. These are the two formulas for hyperbolas. There's two key differences. One is that this symbol in the middle is subtraction. We are subtracting these ratios from each other. X squared over a squared minus y squared over b squared is equal to 1. Let's talk about that a little bit before we go over the properties. One thing is that whatever thing is not being subtracted, whichever one is coming first in this case, is going to determine which way this hyperbola will open. So since x is first, it's going to open on the x-axis, something like that is sloppy. So it's going to open left and right. And this one, when we have y first, it's going to open up and down. Simple enough stuff. There are a few intricacies that we're going to get into now. The first one is that unlike with ellipses, A may or may not be greater than B. With ellipses, A must be greater than B. With hyperbolas, could go either way. The new rule that we have to follow for this, or the hyperbola rule, that we see that A is always with the x's. A is always with the x, and B is always with that y. B is always with that y. So we see A is always paired with the x, and B is always paired with the y. So we saw that it can open left or right or up and down, whichever direction in which it opens, we call that the transverse axis. The other direction, the other axis, we call the conjugate axis. So, these also have vertices. If you consider something opening up and down, The vertex is where it changes direction, or like where each curve comes to its maximum or minimum point. So uh, if a hyperbola opens up and down, remember that b is always paired with y. If this is if we have an xy axis here, if you imagine these are at the points, we just go up however much until we get to b, or down. So it's 0, comma b, and 0, comma minus b. Similarly, if it opens left and right, we just do, that means if it was like this vertex here is the value a away from the origin. So it'd be a comma 0 and negative a comma 0. Let me get rid of that. So all that we can find out just from whatever we can calculate as a or b in the function that's given to us. Okay, these focus points. Let me make another one. We have this hyperbola. Oh, I'm running out of room on my little pad. They're found by using a very similar equation. C squared is equal to a squared plus b squared. So effectively the same as Pythagorean theorem. The only thing is, though, unlike with ellipses, in ellipses the focus points are found within the ellipse. Here they're going to be found outside it, just a little bit outside on the major axis. So the focus points, which are on the I'll say transverse axis, because that's the effective major axis, found on opposite sides of the curves. Okay, last thing they have these things that are called asymptotes. Whoops, I need to get rid of those. Actually, forgot to get rid of my asymptotes. So an asymptote, and you'll deal with this more in Algebra 2, these are lines that the function or the graph gets really close to and approaches, but never touches. And there's a simple equation for those lines. They just use a and b. So there's two of them. Y is equal to negative b over a x, and y is equal to positive b over a x. These are two slanted lines for that. I'm going to stop recording now so we can do an example together.